Alright, section 11.6, surface area and volume of spheres. This is going to be a lot of formulas. There's two formulas in here that you absolutely have to remember because there's no way that you could remember how to do either of these without the formulas. Alright, so some definitions. A sphere, this is a ball. Think a ball. So it's a set of all points in a space that are equidistant from a given point called the center. So all these points that are equal distances from some point out in space. And that makes a sphere. The radius goes from the center of the sphere to some endpoint on the sphere. So any radius, there can have infinitely many radii in a sphere, from the center of the sphere to any point on the sphere. And then the diameter is just like on a circle. It's a segment passing through the center with endpoints on the sphere. So think of whenever we take a sphere, so I'll try to draw a ball here. Something that looks about like that. So whenever you take, say, a big knife and you cut a section off of a sphere, so picture you're taking an orange and you just slice through it. The cross section is a circle. If you look at the edge that you just cut, it's a circle. If you cut the circle or cut the sphere where the center of the circle is the center of the sphere, so picture we're going to cut it right straight across here, then that's called a great circle. Picture the equator is a great circle. So that would be one example of a great circle of a sphere because the Earth is technically a sphere. The circumference of the great circle, so if you take the circumference of the equator, is the circumference of the sphere. And then a hemisphere, you should know from geography, that is a great circle that divides a sphere into two halves. We live in the northern hemisphere. There's a northern hemisphere and a southern hemisphere. There's an eastern hemisphere and a western hemisphere. You take an orange and you slice it exactly in half, you've got two hemispheres. Alright, first formula, you need to know this. Put a star by it, highlight it, put a box around it, whatever you need. Surface area of a sphere is 4 times the product of pi and the square of the radius. So 4 pi r squared. It is that easy. Just plug it in and hit go. Okay, so let's try this. Surface area of a sphere with a diameter of 8. So the surface area equals 4 pi. If the diameter is 8, that means the radius is 4, and we square it. So we type this all into our calculator. We're going to leave it in terms of pi. So that gives us 64 pi in meters squared. Okay, if it's area, the units are squared. If it's volume, the units are cubed. Alright, let's try another one. This one has a diameter of 14 inches. So we do 4 pi. If the diameter is 14, the radius is 7. So we do 4 pi times 7 squared. And we're going to leave this in terms of pi. So that gives us 196 pi inches squared. Alright, let's do this for Earth. It says the equator is about 24,902 miles long. This is circumference. Remember, I already talked about that, how the great circle of the Earth is the equator, and that's the circumference. So circumference is 2 pi r, right? So 24,902 equals 2 pi r. I need r because I have to plug it into the surface area formula. So we're going to do a little division. We're going to take 24,902 divided by 2 and then divide by pi. The radius of Earth is 3,963.3 miles. That's a pretty big radius. So then if we want to do surface area of the Earth And it says approximate because we are rounding and we're kind of guessing on how big it actually is. D4 times pi times 3,963.3 squared. Huge number. So we'll type this in our calculator. 4 pi times 3,963.3 squared. We get, and I have to write this out and then give you the place values here. 389,368.9. So if I go back and put my commas in, that is 197,389,368.9 miles squared. That's a lot of surface area. So if you figure, 70% of the Earth is water, you could figure out how many square miles of water there is on the Earth. All right. A melon. This melon has a circumference of 18 inches. So that's 2 pi r. So if we work backwards, we would have to divide by 2 pi to get radius, right? So radius equals 18 divided by 2 pi. So 18 divided by 2 pi gives me 2.9 inches for the radius of this melon. Not a very big melon, probably like a cantaloupe. So then we do surface area, 4 pi radius squared. Okay, so 4 pi times 2.9 squared. We get 105.7 inches squared. Okay, surface area is not too bad. You got to know the formula. You got to know 4 pi r squared. All right, next formula for volume of a sphere. This is how you can figure out how much liquid to put inside of a basketball if you wanted to, or something like that. 4/3 times pi times r cubed. Somebody really old a long time ago figured this out. Alright, so we're just going to use it. We're going to plug in the radius and go. So, volume of a sphere with a radius of 6. 4/3 pi r cubed. Now you have to watch this. This is multiply by 4, divide by 3. If you want to leave it in terms of pi, you type everything else in but the pi, so you don't get any decimals out of it. So we're going to do 6 cubed times 4, and then divide by 3. That gives me 288, and then we still have the pi there, meters cubed. Okay? If it asks you to leave it in terms of pi, you need to be careful about that. Let's try another one. This one has a diameter of 60. So 4/3 times pi. If the diameter is 60, that means the radius is 30. Okay? So we'll do 30 cubed times 4 divided by 3. We get 36,000 pi. But they asked for it to the nearest cubic inch. So we're going to go ahead and multiply it by pi. And the nearest cubic inch would be 113,097 inches cubed. Okay, you have to read your directions and figure out what you're going to leave your answer in. Alright, this one says volume of a sphere is 5,000 cubic meters. So we would be working backwards. It asks what is the surface area. So we need to work backwards out of volume. Volume is 4/3 pi r cubed. So we have an equation that looks like this. So if we were going to solve this, I'm going to get rid of the 4/3 first. So I'm going to multiply both sides by 3/4 to get rid of that. So we'll take 5,000 times 3/4. And we get pi r cubed equals 3,750. Then you're going to divide both sides by pi. So we're going to divide by pi. And we'll get 1,193.7. Now, see how this is a r cubed? Just like a square would take the square root, we're going to take a cube root. And this you kind of need to see on a calculator. So if you don't quite get where this is coming from, ask me to show you. So on your calculator, you hit 3 second, and then the caret key, and then 1193.7. This gives you a radius of 10.6. If you don't know how to do a cube root on a calculator, you please let me show you. Okay? Alright, so it wants the surface area. So we'll do 4 pi times that 10.6 squared. So 4 pi times 10.6 squared. And we get 1411.96. It doesn't tell us how to round our answer, so we could make this 1412 because of the way it rounds. Okay? Tricky problem. You're going to need some help with this. Make sure you ask how to do it if you don't understand. Alright, one more. It says the volume of a sphere is 4,200 cubic feet. Find the surface area. So we're going to work backwards again. So 4/3 pi r cubed is the 4,200. So I'm going to do this all in one step. I'm going to take 4,200 times 3/4, and then I'm going to divide it by pi. And that gives me 1,002.7. Now I'm going to take the cube root of that. So 3 second caret key 1,002.7. And I get 10.01 as my radius. So then I plug that into surface area. 4 pi times 10.01 squared. And we get 1,259.2 feet squared. Okay, a little tricky, but we can take any formula and work backwards out of it and get whatever we need out of it. Alright, if you have any questions, you need to come see me and make sure you understand.